electrostatic fields are described by Laplace equation. Generally, the Laplace equation takes this form, and we have this phi, which is the electric potential. In most of the cases we are considering in this course, we do not have any dependence in the third direction, so phi is only a function of x and y. Therefore, this third term vanishes. Actually, the derivative of phi is equal to, in the z direction, is equal to 0. Associated with this potential, we have the electric field defined as follows. It's the gradient of the potential function. And this is a vector function which describes the force of a very small particle inside this region. And the direction of this electric field is the same as the direction of the force which is induced on this small particle, electric particle. Note that the gradient of a function is always defined in this way. We have, as in the first component, we have the derivative of phi with respect to x. In the second, we have the derivative of phi with respect to y, and so on. So in our case, we have a easier situation. We do only have dependence in x and y, so the Laplace equation takes this form. We are going to consider the most elementary example of such problem, electric field in a capacitor. So example 1 is devoted to this. We have a capacitor where there is a constant potential along this vertical line. We call it phi 1, and this vertical line is placed at the x value minus 1. Similarly, on the opposite side, we have another vertical line where the potential is assumed to be a new constant, namely phi 2. So along this line, the potential is assumed to be constant, and similarly on this line, another constant. Due to the fact that the potential is constant in these two vertical lines, we can very well assume that the function, the potential must be only dependent of the x variable, so it's no dependence in the y direction. So this means that the Laplace equation is very easy to solve. We have that this second term vanishes because it's no dependence in the y direction, so certainly the second derivative must be of this phi must be equal to 0 with respect to y. Therefore, we only get this trivial equation. Second derivative of phi with respect to x is equal to 0. So what does this mean? Well, if we find the antiderivative of the second derivative, which is the derivative of phi with respect to x, it must be constant. So let's call this constant a. And if we find the antiderivative of this function, well, this is also easy for us to do because it's just ax plus b. So if we just take a check, if we take the second derivative of this function, we obtain this constant, this value 0. So this is satisfied. In order to find A and B, we just use these boundary conditions, phi 1 and phi 2. So this means that the function phi at the x value minus 1 and for all y should be equal to phi 1. Similarly, on the other side, for x equal to 1, this function phi should be equal to phi 2 for every y. So if we now insert this into the general equation or the general expression we have here, it's easy to do this. We obtain that phi of minus 1y is equal to, and here we just replace the value of x with minus 1 because we are at the x value minus 1. So a minus 1 plus b should be equal to this phi 1. Similarly, on the other side, we just replace x with 1 and obtain this situation. So a multiplied with the x value 1 plus b is equal to the constant phi 2. So if we just now look at these two equations, we have this is the same as this, and this is the same as this. We have two variables and two equations, so we can solve these two equations with respect to both a and b. And it's very trivial to do this. We can, for example, we can express this second equation with as a function of b, or express this equation in terms of b, obtain that b is equal to phi 1 plus b, and then we insert this value in the first equation and obtain just this equation. So we have then that a plus a is 2a, and we just move phi 1 on the other side of the equation and obtain that a is equal to phi 2 minus phi 1. So now divide it with 2, of course, and inserting this value of a into this equation, we obtain the similar expression for b. So b is equal to phi 1 plus and then phi 2 minus phi 1 over 2. So in this way we find both a and b. So therefore we have found the value or the expression for this unknown phi xy. Let's just show you this. So replacing now a and b with these values, we obtain that phi of xy is equal to this expression.